All right, let's go through an example with die here, right? Like just a simple six-sided die, and figure out some probabilities based off these complements. So suppose we're rolling just one of these die. What's the sample space? And then let's find the complement to even and rolling a 1 or 2. Okay, so the sample space will simply be 1, 2, 3, 4, 5, or 6, right? Those are the only possibilities when I roll one die. And I want to find first the probability that I get an even number. Okay, well, the first thing I want to do when I get something like that is figure out what that would actually mean. So 1 is not even, but 2 is. 4 is even, and 6 is even. Okay, so that's what that event really is, written out as a set. So there are 3, 1, 2, 3 even numbers out of 6 total. Okay, so now the probability that I get 1 or 2. Well, 1 or 2 would be getting literally 1 or 2. That's these two things out of 6. Okay, now let's look at the complements. So the probability that it's not even, okay, so if I look at that, what things are not even? Well, as I go through these, 1 is not even, 3 is not even, 5 is not even. So there's 3 things that are not even out of 6, and just simply not 1 or 2. Okay, so neither 1 nor 2. Okay, well, how many of these are not 1 or 2? Well, it looks like 1, 2, 3, there's 4 things that are not 1 or 2. Okay, so I want us to kind of notice something here because it'll kind of help us as we go through this. What does 3/6 and 3/6 add up to? 6/6, which is 1. What does 2/6 and 4/6 add up to? 6/6 again, which is 1. Right? That's not a coincidence. What is 1 as a percentage? It's 100%. Right? So what that really means is the probability that I get even or not even is 100%. Well, yeah, there's a 100% chance that it's even or it's not even. There's a 100% chance that it's this or not that, right? So it's that or not that, right? Like it's either 1 or 2 or not 1 or 2. Yeah, that's true. There's a 100% chance it's not either one of those. Well, let's think about it. Isn't that always true? Right? There's like a 100% chance today that it'll rain or not rain. One of those two. Right? There's a 100% chance that you watch this whole video or you don't. Okay, sure. Right? There's always a 100% chance it is certain that something will happen or not happen. Okay? Well, let me write that out. Let me write that out because that's actually going to give us a formula that we can work with whenever we're finding these complements. Okay? So let's just take our generic event that we just call A, right? Sort of like we were using X in algebra. It's just a generic event. It doesn't matter. It could be having a cat. It could be a rainy day. It could be a treatment working in medicine or something, right? It doesn't really matter. It's just some generic thing that's happening. Okay? So the probability that that thing happens, if I add together the probability that it doesn't happen, I am absolutely certain that it'll happen or not happen. One of those two. Well, that's absolutely certain. Okay. We're almost done already. Okay. So I know this is like P of A, and these feel like, oh, it's a whole like probability function thing, and it's confusing to be able to do this. But I'm still allowed the plain like rules of algebra that we had before. So what I'm going to do here is I'm just going to subtract the probability that this A thing happens from both sides of this equality, which gives me the probability that something does not happen is 1 minus the probability that it does happen. This is called the complement rule, and it is way more useful than it seems. And it really just comes from the fact that we're absolutely certain that either something happens or it doesn't happen, right? That's just, there's no middle ground there. It's either happening or it doesn't happen with any kind of event that we would be able to write out like this. So in the next video, I'll go through a couple of examples of this, but this really, this right here, that's the key. Okay, so just understanding, 1, how to write out a complement, and then 2, how to find the probability from it, is really all we need from this section.